What should procurement teams verify before choosing how to verify a 12,000 W external liquid cooling radiator for continuous high-load operation? The answer is not just speed. Buyers need to check whether the solution fits real production targets, delivers stable data, and reduces downstream risk for quality control, maintenance, and supplier coordination. This walkthrough focuses on the practical evidence a buyer should request before moving forward with a purchase decision. An 8-step validation workflow tests 12,000 W rating claims against 6 risk tiers and continuous load duty cycles. Why rated wattage needs verification? A 12,000 W external liquid cooling radiator is an attractive specification for procurement teams dealing with high-power computing, industrial electronics, and dense equipment layouts. The number suggests that the radiator is built for a demanding thermal role. However, continuous high-load operation cannot be verified by wattage alone. A radiator must be assessed against heat source profile, coolant flow under restriction, pump head, airside performance, sealing behavior, material compatibility, maintenance access, and supplier evidence. The difference between a headline rating and operational reliability becomes especially important when equipment runs for many hours at high utilization. A short duration test, a favorable ambient condition, or an open-air demonstration may not reflect a factory cabinet, AI workstation, test bench, or server prototype running under sustained load. Procurement teams need a validation process that converts product claims into measurable engineering questions. Okaku BC12 is used in this article as a practical example because the product page lists 12,000 W rated heat dissipation, 17 plus or minus 1 liter per minute maximum pump flow, 11 plus or minus 0.5 m pump head, 15 fans, 40 waterways, pure aluminum construction, and G1/4 threaded interfaces. These specifications create a useful basis for verification, but the final buying decision should still depend on application-specific evidence. 1. What rated heat dissipation can and cannot prove. Rated heat dissipation can indicate the intended scale of a radiator. It does not prove that a given installation will maintain safe temperatures under all conditions. The rating may depend on coolant temperature, ambient air, fan speed, airflow path, coolant chemistry, radiator cleanliness, and acceptable temperature rise. Buyers should ask suppliers to explain the test environment behind the number. 2. Difference between peak cooling claim and continuous operation. Peak cooling claims can be useful in marketing and preliminary comparison, but continuous operation is a different question. Sustained heat loads expose weak pumps, clogged channels, fan fatigue, inadequate airflow, poor coolant selection, and small leaks. A procurement process should therefore evaluate durability, not only capacity. 2.1 Heat load, ambient temperature, coolant, and airflow as hidden variables. The same radiator can behave differently in a cool laboratory, a dusty workshop, a warm server room, or an industrial cabinet. Coolant composition changes heat transfer and corrosion behavior. Ambient temperature changes the radiator-to-air temperature difference. A strong buying decision depends on more than a good brochure. Teams should compare measurement range, repeatability, calibration method, sample preparation requirements, maintenance support, and evidence from real plant use. When those checks are completed before purchase, the business can reduce retesting, avoid production delays, and choose equipment with more confidence.